Okay, good morning, everybody. This class is going to be Refrigeration Basics. Basically, what we're going to do before we install the equipment and how to install the equipment. A little bit of best practices, what things that we should be doing on every job, just to try to keep everybody from having callbacks. I mean, I consider that my number one priority is to get you out there, get you through a job without having callbacks, because that's the killer of our industry. So if you do the basics, you're going to have very few problems with your jobs. So let's go ahead and get started. My name is Jim Stevens. I'm your FSR for the mountain region. I have Eastern Washington, all of Montana, and various places east of that. So all the guys over there know me, and most of you know me from just talking on the phone. So I recognize a whole bunch of names on here. I appreciate you attending today. Our number is 253-620-8282, and that gets you into our call queue. And you can either call or text that number, and you're going to get one of the two guys that's in the office on that week. Remember that we're out teaching and doing job site visits on opposite weeks. So myself and Mike are on in the office this week. Jeremy and Jamin are out in the field this week, and next week we switch off and we just keep going like that. So if you guys need anything, call the number in the center. You'll get faster service instead of trying to contact one of us directly. Installation considerations, what we're going to talk about today, basically. Airflow. That's the number one reason that air conditioning and heat pumps don't work. It's the most of the calls that we get center around airflow, and a lot of people don't think that because it has a pressure issue, a charge issue. It's throwing some kind of codes, and it's almost always airflow before you can charge to get the charge correct. So you have to do your airflow first and then the charge. We're going to talk a little bit about refrigerant lines, outdoor units, indoor units. There's things that we have to do before we even set the equipment. Looking up the correct equipment, checking what our airflow is going to be with accessories, even backup heat. Reduces our airflow through the air handler. So we need to know what size so we can calculate into our ductwork and our jobs, whether it be new construction or retrofit. We still need to know what the airflow going through the system is so that we can offer other things if we need to. Gensco and our manufacturers have always recommended approved matched indoor and outdoor systems. The benefits of installing approved match systems are maximum efficiency, optimum performance, and best overall system reliability. The other thing is that if you're trying to put a 410A system on an older coil or air handler, there's a potential there that indoor unit is going to blow up. And what I mean is blow the lines inside of the coil because they were never designed for the higher pressures of 410A. So we need to be careful for this stuff, okay? HRI directory, comfortsite.com, asdealer.com, genscocustomer.com. Those are all places that you can get the matches. It's very easy. You go in to ComfortSite or DealerNet, you select your outdoor equipment, you select your indoor equipment and the tonnage, and then you go and it brings up a whole list of all the different indoor equipment, okay? So I'm getting a note saying my audio is fading in and out. Is it better now? Okay, give me just a second here. Let me get my audio fixed. Alrighty, I hope that's a little better. All systems must have a heat loss and heat gain for sizing. No exceptions. If you're not doing that, you don't know what size the house needs for you to put in the correct equipment. I know a lot of people try to match off of current equipment, but if the original guy didn't do his job and we don't know whether they did or not, you're going to have issues with airflow, noise issues, overall system capability. You need to know what you need for the house before you can install it. So do a heat loss and heat gain on every job. So installation considerations. When you get the equipment at your job site, you want to make sure it's the right equipment. Make sure it's the correct size, the correct efficiency, the correct voltage. I've had units come in the box that had the wrong information on the box, and we actually had it, and it was just it was a furnace. We had a downflow furnace and an upflow box. The guys looked at the box. Oh yeah, great. They installed it. They took the covers off the front, and oh geez, it's the wrong furnace. So if you just look at the stuff before you install it, you're going to save yourself a whole heck of a lot of time. And this goes for the office people and the salesmen. They need to make sure that they're putting on the correct equipment at the job site. I've had a few lately where they're putting three-phase into apartment buildings and things like that. So we need to be careful that we're getting the correct voltages of the equipment. Don't assume, look at the old equipment or look at the actual panels before you buy the equipment. Check the product data sheets, the installation guides, and the service facts for install related issues before you install it. Two-stage units require variable speed indoor motors. Don't forget that. Is the airflow correct? Can you get 400 CFMs per ton out of the indoor unit that you're proposing or that's existing? The condensing unit has to be level. And don't forget that heat pumps need to be on pump ups. They need to be 12 inches above snow level. We have those racks that work for mini splits. We also have those for side discharge units. We used to build, I live in Spokane, Washington area, Spokane, North Idaho, and we would build our own platforms to get units up out of the snow in the snow belt. I mean, we're talking, 3 feet of snow in one night. Now, it doesn't happen all the time, but when it does, we need to be prepared for that kind of stuff. So remember, 12 inches above the snow level. And why 12 inches? That way, in case we get some extra snow, because we're talking about normal things, right? So normal snowfall, if you normally get 12 inches a year, it needs to be 12 inches above that for the storms that we get every once in a while. The refrigerant piping program is something else that's really cool, and we'll go over this at the end. I want to show everybody the refrigerant piping program. It's your code in your area. I'm sorry, I keep kind of going back, but I'm getting questions. I'm going to hold off on the questions until we finish the section, and then we'll go through and we'll do all the questions all at one time. Okay, so give me a few minutes to get through this, and then when we have a break, we'll answer the questions. The refrigerant piping program is in DealerNet and Comfort Site. If you go into the Comfort Site or DealerNet, go to Tech Support and it's the top one inside of tech support for refrigerant piping program. That's the same program that the FSRs have been using for years. This one's coming direct from Train. It's updated by Mitch at the factory. He did a really good job on this program. And you can go in and put in your length, the height, the equipment, everything related to your job, hit go, and it's going to tell you if you can install it. It's going to give you alternate line size lengths, and it's going to give you the amount of refrigerant you need to add for that extra length. So it's a really good program. It's also going to, in the notes, tell you if you need a crankcase heater or a TXV or any kind of extra stuff. If you're going a little long with your line set, it's going to tell you what you need to install with that equipment for that extra long line set. Very, very good program. Why is refrigerant piping so important? Oil return. If we have suction line velocity issues, if our line set is too big or too small, we're going to have capacity losses. We're not going to get the oil back to the compressor where it needs to be. It's going to stay out in the system. It's going to stay in the line set and in the indoor coil. We're going to have major issues with killing compressors. Okay. Flash gas. If you have flash gas in your liquid line, you're not going to have liquid at your metering device, and you have to have 100% liquid at your metering device or you lose capacity big time. Flood back to the compressor. If you have flood back to the compressor, you're going to kill your compressor. Liquid in the compressor, bad news, right? Everybody knows that. We cannot compress a liquid. That's why they sound so bad when you get liquid in them. And if you're charging and if you're hearing the compressor starting to make noise, slow down your charge. Shut it off for a minute until the noise goes away. Start again very slowly. We do not want to kill any compressors or cause any scalding on the plates of your compressor. Okay. Make sure that we're meeting minimum distances. Know what your applicable codes are in your area. Make sure that you're away from utility meters, dryer vents, stuff like that. I went to a guy's house where they live up in Cooley Dam. We went to the house, and the call was for a unit not defrosting, and they'd already replaced the defrost board and the sensors and everything. And we get there and we pull up in front, and I can see what's wrong already. They put the unit right in front of the dryer vent. The moisture off the dryer is coming out, hitting the outdoor unit and causing it to freeze up more than it should. Well, when you're adding so much moisture onto the coil, it's not going to defrost all the way. And what was happening was the coil was actually defrosting. It was the metal screen on the outside of the coil that would not defrost, because you can only defrost the coil because that's the only spot that gets hot. Okay. So all of the ice that's forming on the outside of the unit was not being defrosted, causing the unit to have issues. So those are the kinds of things we need to look at when we're installing it. Just look around, look at the area where you're going to be putting it, and be careful where you're putting the stuff. In a coastal area, put it on the opposite side from the waterfront. Try to keep the water spray off as much as we can. There is a piece of plastic, looks like visqueen, inside of the units that cover up the reversing valve and the TXV and all that stuff on the outdoor units. That is in there on purpose to keep the salt spray off of those components. If you pull that out and you're near the waterfront, you could have a lot of deterioration from that. That's why that's in there. So don't take it out if you live in that kind of an area. Now, if you live in Montana, places like that where we don't really have humidity, Idaho, where I live, we don't really have a lot of humidity. We don't have any salt in our air. So you can take that out. But on a on a coastal area, make sure that you leave it there. Maintain your clearances, adequate airflow, make sure you have serviceability. I know that the book says 24 inches, but what about electrical code? Electrical code's 36 inches. So we need to remember that although we only need 24 inches for the mechanical code, the electrical code says 36. So you need to be careful how you install that equipment. Don't put it in an objectionable area. Don't put your outdoor unit right next to the bedroom. It's a mechanical piece of equipment. It is going to make noise. Okay. That's just flat out it. It's going to make noise. So don't put it on the patio. Don't put it under the bedroom window. You know, put it out by the garage where there's nobody sitting in there or trying to watch TV or sleep all day. Things like that. It's just a little bit of common sense in the beginning. It's going to save you a lot of issues and homeowner issues later. Make sure that you're putting your unit outside of the drip line or all the way inside of the drip line. I know now they're making some houses that have 4-foot eaves. So you want to be careful that you maintain your 5 feet above the unit to the eave, and then don't let the water drip inside the unit. You'll get fan blade damage, motor damage, the outdoor coil damage, because remember, the defrost only defrosts the coil. It does not defrost inside of the unit. So if you've got water dripping off when the unit's off, you've got water dripping off the roof into the unit, it can freeze and build up like a cone right on the inside, and it can break pipes, it can crush coils, it can take out fan blades. So make sure that your units are outside of the drip line or all the way inside the drip line. And remember, we still need to maintain our 12 inches on the standard unit and 6 inches for a side discharge. Leave room to work on the unit. Remember, somebody's going to have to come back and work on this unit. So please leave room. This is an actual install. It's an old picture, but this was an actual install found in the field. And everybody can look at this and tell this is not right. You can't get into it. You can't get to any of the components, you know. So I'm sure that the homeowner built this after, but you never know. So make sure that we're looking at it, okay? So these are all the things that we need to do before the install, okay? So let's go through the questions real quick. So it says, why 12 inches? So 12 inches is in case we have a storm. So you take your normal flow, your normal snowfall, and then you want to add 12 inches to that for the storm, okay? Now, up here in North Idaho, what we do is we tell people when we install it that you're going to have to go out and shovel around it when it snows, okay? If we get a storm that's 3 or 4 feet deep, you're going to want to put it into emergency heat until you can get out there and shovel it out. You don't want to let it get covered with snow. Now, I know that we don't have those kind of storms all the time, but every once in a while we do. So you're going to want to remind your customers that they're responsible to go out and keep it clear. Code is whatever code is in your area. Everybody lives in a different area. Code is 12 inches above the snow level, okay? So if you're installing 6 inches above the ground level, you must not have any snow. If you get snow, it should be higher. Now, I know, and I've been doing this for a long time, that's what most people do. They put 6-inch pump ups and they don't have issues until you get the big storm. Well, the problem is when you get the big storm and it starts crushing coils and stuff like that, who's responsible for it? Okay. So again, my job is to make sure you don't have callbacks, you don't have issues. So I'm telling you what the recommended things are, and what you actually do is entirely up to you. But it should be 12 inches above. Now, here where I live in Spokane, Washington. We get snow, but we don't get 12 or 16 inches all the time. We usually get a 2 or 3 inches on the ground, maybe 6, and that's it. So most of the guys around here put our equipment on 6-inch pump ups. But I was just at a job this year where we had a storm that blew 3 inches of snow, and this guy had a house that was kind of out on the prairie. He was getting snow drifts up the side of his house, and he actually had snow drifts high enough that covered his heat pump. It took out the coil on his heat pump. The water, as it was defrosting, went down into the heat pump, and what happened was the snow got underneath it, blocked the drain holes on the bottom of the heat pump, and it actually crushed the bottom of the heat pump coil. So is that an install related issue? Is that a weather related issue? I don't know. If they would have put that unit on one of those quick slings and raised it up a couple feet, we probably wouldn't have that issue. But how do you determine that? It depends on where you live and what kind of snowfall you get. The link for the piping program is not really a link. It's in ComfortSight and DealerNet. So you have to have ComfortSight or DealerNet access. And then you go to tech access or technical support, and then it's the top one in technical support, the piping program. And again, when we get through with this, I need to get out of the PowerPoint, and then I'll bring it up on ComfortSight and we'll look at it. Electrical service clearance trump installation manuals and recommended clearances. Absolutely. Your local codes can be stricter. So what you want to do is go by the stricter rule. So yes, electrical service clearance trumps installation manuals. Now you remember that our books don't really talk about electrical. The only thing they do is tell you the amp draw and the size of the fuse. Everything else is left up to the electrician. Okay. So what we need to do is make sure that the electrician's installing it according to code, and that we are placing the equipment where the electrician can get strict walk right up access to the electrical portion 3 feet. Sealed systems must be kept clean. You must use new line sets, deburr the copper ends, clean the copper ends with emery cloth or a scuff pad to clean it up before you braze. Remove the valve core when you're brazing. If you don't remove the valve core, you're actually fuming rubber into your system off of the O-rings on your valve cores. Okay, so make sure that you're removing the valve core when brazing, and it also makes it easier to evacuate your system. It makes it easier to charge. And if you're using a charging tool, you could use the valve core removal tool. Use that when you're charging, and then you can put the cores in after you're 100% finished. It's going to make your job go by very much faster. Always flow dry nitrogen through the lines anytime you're brazing. When you're installing a piece of equipment and you roll out your line set, you set your outdoor unit, you set your indoor unit, don't cut the line set and don't open the line set to the atmosphere until you're ready to braze. What I always did was I got it in position. I did all my bends. I got it ready. I didn't take the caps off the end until I was ready to unplug the line set, take the cap off the indoor unit, and plug in the line set. There is nitrogen inside the coil. There is nitrogen inside your line set when you get it. So if you were to cut off the line set, plug it right into the hole, very little air is going to get in there. Very little moisture is going to get in there. So that when you flow your nitrogen through and braze, by the time you're ready to put on your vacuum pump, you're not going to have any air or moisture in there on a new system. Your evacuation is going to go very fast. You're going to be able to pump it down, and every time that we pump it down, we're going to pump down by micron level, not by time. So throw your micron gauge on, pump it down. As soon as you get down to where it needs to be, shut it off, make sure it doesn't rise, and off you go. Okay. You can do this very quickly if you're careful how you treat your line sets. Okay. Make sure that you're using a neutral flame for brazing. Be cautious of the temperature sensitive components and combustibles. Wrap valves, wrap the TXV bulb, or remove it. Sensors, wrap everything with a wet rag. Now on air handlers, take the suction thermistor off before brazing. If you don't do that, you will melt it. You will cause damage to it. And that makes your EEV not work correctly. That makes your charging incorrect. So be very careful with those suction thermistors. Take the door off. Cut the little wire tie. Peel off that piece of insulation. Stick it on the side of the furnace. Take that sensor off, do your brazing, wait for it to cool off, put everything back, put a new wire tie on it, boom, you're done. You don't have to worry about replacing a thermistor if you do it that way. Believe me, we sell hundreds and hundreds of thermistors because they got messed up on installation. Okay. Again, that's where the suction thermistor is on the coil. Take the door off, cut the wire tie, pull the insulation tape off, remove the suction thermistor. You can just let it dangle there, put it right back in the same spot, put the insulation back on, and put a new wire tie on. You can see how close that is to that 3/4 or 7/8 line. You are going to melt it. There's just nothing you can do about it. Okay, so take it off. Don't even take a chance. This is an EEV brazed without nitrogen. You can see the contaminated valve, see all the black soot on there. You can see where on the seat, on the round part on the bottom, that's the seat, where that pin goes into the seat, you can see where there's black stuff around the opening. Well, there's going to be refrigerant going on the clean spots down in because it can't push through that soot. So it's going to actually cause it not to close all the way. This can actually get in there, and where the valve body is, this soot can actually build up there and then it'll stick part way. So it'll work sometimes and work and not work sometimes. So you go out to troubleshoot it, and it works today because it's 75 degrees outside and the valve's kind of in the middle. So it's going to open up a little bit and close back down. It's not going to try to open all the way because it doesn't have a big heat load. As soon as it gets hot outside, it tries to open up all the way. Now the AC doesn't work right because of the contaminated valve. Okay. So this makes our jobs a lot harder. If you go out and you check everything out today because it's a decent day, everything works fine. And then as soon as you get a hot day, boom, it doesn't work. So what happens? You go out and you check it. The hot day, then they call, and then tomorrow it cools off again. You know how our weather is. So if we don't have this issue because we're doing the best practices correctly, we can eliminate that as a problem. Moisture will compromise the performance and operation of the system. Don't open the service valves until you're ready for startup. Leak check the system as soon as it's finished brazing. Pressurize it to 150 pounds of nitrogen. I know some guys use more. I took that right out of the book. Okay, I took it right out of the book. Train in American Standard, Run True, Ameristar, all say pressurized to 150 pounds. You cannot pressurize it to 600 pounds like you would a mini split. Our valves will leak through over probably 350 psi. So if you stick with the 150, you're going to be better off. If it doesn't leak in a half an hour at 150, it's probably not going to leak at 300 either. Okay, so just remember, don't over pressurize it, because you can push nitrogen right through those valves, right into your refrigerant inside of your condenser. Okay, never test with air. Air and refrigerant oil can become combustible. Always use dry nitrogen, and use dry nitrogen every single time you raise, no exceptions. As soon as you're finished with the pressure check, release the pressure, hook up your vacuum pump, do a triple evac down to 300 microns, shut the valve off, go into your unit, shut the gauges off. It should not rise above 500 microns. If it does, you need to turn it back on. If it does it again, you may have a leak or you may have moisture in your system. Okay, those are the two things. Using the triple evacuation, what it actually does is our vacuum pumps are so efficient now that as they pull down, they'll freeze the moisture inside the pipes. So by doing a triple evacuation, and what that means is pumping it down to about 1500 microns, bring it back to 0 with nitrogen, pump it down again, down to about, 1000 microns. And then if it's coming down nice and steady, you don't need to do it more than once. But if it's not coming down as fast as you think it should, do it again at 1000, and then go down to 300 microns. Okay, shut the system off, shut your gauges off, and it should not rise above 500 microns within a minute. If it does, you either have a leak or you have moisture. This is a couple of different micron gauges. There's different ones out there. My field piece gauges have a micron gauge on them already. So there's all kinds of different ways to do it now. Just make sure you're using a micron gauge. Replace the liquid line filter dryer anytime the system is opened after the initial install, and make sure that you're installing it on install. It comes with the Trading American Standard units. You need to add it to an Ameristar and Run True unit. So make sure you're putting one on every single unit. 410A oil will not boil off like R22 oil did. Okay, so you have to use they will have to use I just lost my mind. You have to use a filter dryer on all of our systems, and it's because we don't know how much moisture is left in the pipes even after we do our evacuation. We can't get the moisture out of the oil. That's where I was going. You're supposed to check for tubing rubs on the equipment. Open up the side doors, check the tubing rubs on all the cap tubes, make sure that they are not rubbing against each other. Okay, they've done a whole bunch of different things at the factory. They go through before they send it out. On the line, the last person puts their finger in between all of the tubing to make sure that they're not touching. They're putting heat shrink on a lot of the tubing now so that they don't rub. But remember, it gets put on and off a truck several times before it gets to us. So make sure that you're checking for tubing rubs, for loose wires, loose set screws on blower wheels, on fans, all that kind of stuff. Anything that can get loosened by vibration and traveling, you should be checking on install, and you should be checking it on your service calls, on your maintenances. You should be checking all that stuff again every time you go out there, because the unit is going to vibrate. It's a mechanical piece of equipment. It vibrates. It's going to make a little bit of noise. So just remember that as you're doing all your stuff. Fill out a startup sheet on new install and on any major component replacement. okay? The new equipment coming out the link, you're going to have to do a startup sheet. And basically, it's part of the program built into Link. And we've got Link classes coming up starting this week in different areas. So make sure you get signed up and take the Link class. We're going to go over all the Link components, all the Link startup, everything Link. I've got a question on here for Jeremy. Yes, Link still needs micron gauges. The refrigeration is still the same. We do have a charging. The unit will charge itself in air conditioning mode with the charge master. In heat pump mode, you still do it the same old way. If it's too cold outside to charge by AC, you're still going to weigh in the charge and come back in the summer to verify. Same as we do right now. Okay. Airflow is critical to charge. So if we don't have the correct airflow, our charge is not going to be correct. Okay. Proper ductwork is critical to airflow. Like my picture? I got this one out of a book that showed actual installs. You know what? It probably worked fine. You know, on the milder days, you know, they're trying to cool off their bedroom. It probably worked fine, but we can't be doing that kind of stuff. Is it the equipment or the system? Cannot get the proper performance from the equipment with the correct airflow and cannot accurately charge the fixed orifice or TXV system without the correct airflow. So what do? We find out what our airflow is. We need to know what our CFMs are per ton through the equipment so that we can see if it's within 10% of the listed rating in the HRI. 400 CFMs per ton for heat pumps is normal. 325 to 350 for an AC is normal. If we're 10% off of what the rated is, that's the compressor killer. Okay, compressors die because we have too much airflow or not enough airflow. So if we're not verifying our airflow, we are not setting up the equipment correctly. How are we going to do that? We can take a temperature rise and do a calculation. We can take static pressure and use the pressure charts in the book. These are the BTU output. These are calculations on how to get BTU outputs from delta T times CFMs times 1.08, and it depends on the altitude correction factor. That's what that 108 is in your area where you live. So if you're at sea level, it's 1.08. Where I'm at 2,000 feet, so it's 1.00. And I've got places in Montana and stuff like that where they're 4,000 feet, so they're doing 0.93. You know, if you're up on the mountain, you need 0.90. So if you do these calculations, put in your correction factor, do the calculation like this first, use the 1.08. Sorry about that. And then put in your correction factor and see how many CFMs are different. I've been to places in Montana where we do that calculation at 4,000 feet elevation, and we're 600, 700, 800, 1,000 CFMs off of what it's set up for at the factory. Okay, so just because it says 1,600 CFMs, you know, when you set it up, it doesn't mean it's actually putting out 1,600 CFMs. Okay, so you need to do some kind of a test to verify your airflow. BTUs per hour equals volts times amps times 3.413. That would be for an air handler. Again, we already talked about the 1.08. That's the correction factor for specific gravity at different altitudes. We can change the equation a little bit using algebra, which we swore we never used when we were in high school, but we probably use it every day in our industry. So BTU output equals CFMs. So BTU output divided by delta T times the specific gravity equals CFM. So you're going to take the temperature rise across the furnace. You're going to check the BTU output of your gas valve. So say you have a 100,000 BTU furnace at 95% efficiency, it's 95,000 BTUs. So 95,000 divided by your delta T times 1.08 equals the CFM. That's for a gas furnace. For an electric furnace, you're going to take the volts. So you're going to measure the voltage coming in times the amps. You're going to average the volts between the breakers, and then you're going to add up the amps. So if you have 4 elements in there and you've got 2 sets of breakers, you're going to add up the amps for both breakers. Okay, times that by 3.413. That's the BTU value, and then we're going to get CFM. Okay, volts times amps times 3.413 divided by the delta T times the specific gravity, and that's going to give us CFM. Now, I know I'm going through this a little quickly, and you're not going to remember these. These are on the Gensco Tech form, the quick form for doing a job site. Okay, it's right up at the top left corner where the gauges are on the form. So you don't have to remember these. You just have to remember that these are available for you. With our equipment, our gas furnaces, if you look in the service facts, it's going to show you a chart that says BTUs by temperature rise. They've already done the math for you, put it into a chart in the service facts. So all you have to do is take your delta T, look at the delta T, go down to the CFM. It's pretty easy. So here's the example: 95% efficient, 100,000 BTU furnace. Return air is 75 degrees. Supply air is 130 degrees. We're going to do our calculation: 95,000 divided by 55 times 1.08, and that's going to give us 1,600 CFMs. So those of you who live in a higher altitude, you should probably do this calculation right here with your number and see what your CFMs really are. They're probably going to be higher. And if they're more than 10%, you're going to want to reduce your airflow to get it down to the 1,600 so that you're not having issues with your compressor. Okay. This is an example for a 20 kilowatt air handler. So we've got 238 volts and 79.3 amps. We can assume that this is either a single point connector or we've already added up our amp draws on our separate breakers. Okay. Our return air is 60 degrees. Our supply air is 110. We're going to do the calculation: volts times amps times 3.413 divided by the delta T. Delta T is temperature rise, return minus supply, times 1.08. There's our math. There's our delta T. And there's how many CFMs. These are very easy to do on site without any special tools. All you need is a thermometer and a calculator. Okay. Static pressure. Static pressure is the balloon pressure inside the duct. Okay. So what we're going to do is we're going to measure the total static pressure by taking readings at the inlet of the furnace or the air handler at the return. And then we're going to take a reading at the supply of the furnace before the coil or the air handler right at the outlet of the air handler. The reason we have to take it before the coil on a gas furnace is we can have multiple different coils, even different brand coils attached to our gas furnaces, okay? That's why they cannot tell us what it is on the outlet of the coil. So we can take the total static through the coil, or we could take it through the gas furnace itself. Both of those components have static pressure charts inside of the book, service facts, and we can calculate our static pressure that way. On an air handler, the air handlers have the same coil in them, okay? We don't change coils inside of air handlers. So if you have an air handler, you take the static pressure from the return to the supply, and that's how those charts are built, okay? You're going to need a magnehelic or a pressure tester that goes up to 1-inch water column, a hose with the static tips, service facts for the furnace or air handler you're working with, and then you take your measurements, go to the service facts, and look at the charts. This is what a magnehelic looks like. Yes, it's old school. It's the most accurate one out there. If you have an electronic one and you want to verify that you're accurate, you're going to use one of these to calculate the accuracy of your electronic pressure tester, okay? The picture on the right, that's a static pressure probe. You can see the little, almost see the little dots. It looks like pepper on the angled part of that probe. That's how you know that we're measuring the balloon pressure of the duct and not the velocity pressure. The velocity pressure would have a hole on the end of that probe that allows the velocity to be measured, okay? We don't want the velocity, we just want the balloon pressure. That's what we're looking at. So this is a gas furnace. We're going to go from the return as close as we can to the furnace to the supply before the coil. This one for an air handler, we're going to take it at the return to the supply as close as we can to the air handler. And then we're going to go in. This is an S9X1 gas furnace. We're going to take our external static pressure and we are going to look at the CFMs and we're going to determine what the CFMs we need at what speed tap. Okay, if there's little dashes there, that means you're not going to get that pressure at that speed tap. You're just not going to get anything out of it, basically. This is a torque motor. On all the torque motor furnaces, if you'll notice in the books, they do not give you a setting for airflow. They tell you to check the total static pressure, and dependent upon the total static pressure, this is where you're going to set it to get the volume of air you need. Okay. For the torque motors, you're going to go into the little mini CDA on the board. You're going to select the menu till you get down to the compressor operation speed tap. And then you're going to hit the option until you get to the cooling tap that you want. And on that same page where the tree is, shows you how many CFMs on each one of those speed taps. And it also shows you right there on the tap. So you go down, if it's a 3-ton unit, you're at 0.7 static, 1273. You could go to speed tap 8, that's 847, that's not enough for a heat pump, so you're going to use the 1273. Okay. How about with an ECM motor? So we're going to go to the ECM motor, and you notice that the ECM motors, the volumes of CFM are pretty much the same across the board. So what we're going to do is we're going to take our static pressure just to make sure we're not above 0.9. If we're above 0.9 on this furnace, it's not going to maintain your pressure or your CFM. You see where it starts to drop off at 0.9? It's already down to 900 CFM on the 2.5-ton normal. If you look at the 1,000, 900. So it's already starting to drop off at 0.9. So if you go to 1.0, we're probably going to be down to 850, 800 CFMs per ton or for the unit instead of where we want it. Okay. So on the left-hand side, that's the tonnage of your equipment. The next one is low, normal, or high. Do you want, is it for AC? You're going to set it at 350 for an air conditioner only. For a heat pump, you have to set it at 400. Okay. So all heat pumps need to be set at 400 for charging. This is the TEM4 3-speed PSC motor. You're going to change the speed tap on a PSC by moving the wire. Okay, so this is a single speed unit with a 3-speed motor in it. Okay, so it's only going to have one wire that's going to go to the speed tap. So you're going to change that to whatever speed tap you want. And this is the TEM4. It's going to show us the speed taps, high, medium, or low. And it shows us the static pressure and what you can expect at those speed taps. So that's for a GAM2 and a TEM4. This one is for a torque motor on an air handler. The common is 24 volts common to speed tap 1, 2, 3, 4, 5. So most of these are going to have a low speed red wire and a high speed black wire. So you're going to set low speed, you're going to set high speed, and some of them are 2-stage. So you're going to set a low fan only. You're going to set first stage cooling and second stage cooling. So that could be up to 3 speeds on that blower. Again, here's a GAM5B, which is a variable speed, and it's going to show us the speed taps. Actually, I lied. This is a torque motor. It's going to show us the speed taps according to external static pressure and the volume of air going through it. Now, when we're doing a air handler, you also need to look at the chart that's on the bottom there. That is the minimum speed with different heaters. Okay. So with that Bay EABC15BK1, your minimum speed with a heat pump is tap 4. So you cannot put it on tap 3 or tap 2. You have to use tap 4. This one is for a TEM6, which is a variable speed unit. Again, static pressure on the right. We're going to have our dip switch settings. We're going to have our tonnage, and we are going to set it according to our static pressure. We're also going to look at our airflow matrix on the nameplate of the electric heat, and it's also going to give us a static pressure differential. So if you look on here, the number of racks, if you have 3 racks, it's going to drop your pressure on an 1800 CFM at 0.06. So you have to subtract that from your total airflow. The number that you have on your chart, if you measured 0.7 and you're trying to determine your correct airflow, you need to take the 0.06 off that 0.7. So it's actually going to be 0.64 instead of 0.7, right? And over here, there's also a chart that tells you how many racks for each different strip. And then you go over how many racks, whatever unit you have, how many racks, go down to how many CFMs you're trying to go to. And that's what you have to deduct from your total to get the correct CFM. I know it's kind of a pain, but this is how you set it up to get it right on. This is for a TAM9, TAM9 air handlers, TAM8, TAM8, TAM9 have the CDA on the front. You're going to go to the configure menu. You're going to scroll down until it says CFMs per ton. You're going to tell it how many CFMs per ton you want. 400 CFMs for cooling. You go down to heating, tell it 400 CFMs. I don't know why they put 430 on this. slide, you want it at 400 CFM per ton, especially for variable speed outdoors. For charging, it has to be at 400 CFM per ton. And then if we need to increase the airflow for operational reasons, sometimes we do, you still have to charge at 400 because that's where the charging charge is set for. Then you can change your airflow on variable speed if you need to, okay? For heat pumps, standard heat pumps, 400 CFMs, that's where you want it set, okay? Then you go down, you go to the outdoor tonnage, tell it what ton the outdoor unit is. While you're in there, you should tell it what type of electric heat it is and set up your electric heat strip size so you don't have to go back in there twice. Now that we've done all this, now we can charge the unit. Now we can get down to the good part, okay? So we've gone through, we verified our airflow, we've set our equipment correctly, we've made sure that there's nothing going on with it. Look inside the unit to make sure there's no damage before you solder it in. Once you solder in the equipment, we can't do a freight damage claim anymore, okay? We have to do, basically we have to repair it. So if you have a unit that comes damaged from the factory, say you have oil sign inside on the bottom of the box or inside the unit, you're going to want to verify that that unit actually has a charge. All you have to do is take the cap off. Take your pen or your tweaker screwdriver and just push in on the Schrader valve just momentarily, just to go to see if it goes. If it does, you know you have refrigerant in it. Remember, these units didn't get built yesterday. They were built weeks or months ago, and then they get shipped to us. And by the time they go to our office, your office, everything, if it still has refrigerant in it, it probably does not have a leak, okay? So the oil in the bottom of those units could be just when they charge it, because the way that they charge them now is they have these jigs that they set up and they actually put it into the service ports where you're going to solder in your pipes. They actually put a jig in there and open up the service valves. They charge through the service valves. They pressure test, evacuate, and charge through those valves. And then they shut those valves off at the end. Sometimes when they pull those hoses back off, there's some residue left in there, and it just like we do when we take our hoses off, okay? If they don't do it fast enough, it can squirt some oil into the unit. Sometimes they wipe it off. Sometimes, just like everybody, you get a lazy guy who doesn't do it, and it looks like there might be a leak when there's really not a leak, okay? So just look for that kind of stuff. I had a guy call me a couple of weeks ago. They installed a condenser and the fan fell off. They hadn't even started it up yet, but they soldered it in before they looked. Then they look inside and the fan fell off and fell inside the unit and actually cut the refrigerant lines and lost all the refrigerant. Well, they soldered it in. So now we cannot get freight damage. We can get hidden freight damage. You can return the unit. We'll give you a brand new unit. No problem. Now we have to fix the unit. Okay. So just letting you know, look inside the equipment before you install it. Take the doors off. Look inside. Make sure all the components are there. Make sure that nobody's cut all the wires inside of it or, weird stuff like that before you install it. It only takes a couple of minutes and it'll save you a whole heck of a lot of time. Okay. So now that we've gone through, we've pressure tested our unit, we've evacuated our system down to 300 microns and it has not raised above 500. We know that the unit is ready to go. We're going to open up the service valves and we're going to start the unit. Okay. So we're going to open up the valves. We're not going to add any refrigerant. We're going to open the valves first. The reason is that we've had units coming out of the factory that had too much charge and not enough charge. So what's easier to do, add charge or remove charge? Well, you're supposed to pull out your reclaimer and your bottle, to remove charge. So that's how we got to do it. Okay. So don't add charge at the beginning. Start the unit and add charge to subcooling in air conditioning mode. Okay. So we're going to let it run for 20 minutes. We're going to add our refrigerant a little bit at a time until we reach the subcooling that's listed on the outdoor unit. If we're charging with a coil that has an orifice on the inside, then you have to charge by superheat. So you still need to get your subcooling, but then you need to adjust by superheat. So you're going to adjust by superheat for what it says inside your coil book to get the correct superheat with an orifice. Okay. If the outdoor temperature is below 55 degrees, you can weigh in the charge and then you can go back and verify it in the summer. Okay. Because you're probably not going to be starting up the AC when it's real winter outside. You know, it's not good for it. So you probably don't want to do it. What I always did was I would weigh in my charge and then I would just bump the contactor just to make sure my electrical was right and that it is going to run. Just enough to hear the compressor kind of try to start, and then I would shut it off. I never ran it when it was really cold because I don't want to break the compressor. So this is how we charge for air conditioning mode. Okay. In the service facts, there's subcooling charge correction charts. So when you're looking at the subcooling on the outdoor unit, depending on the total line length and the lift of your refrigerant line, you may need to add subcooling to that number on the outdoor unit. Okay. So if you look at those where it says design subcooling, use the design subcooling. Then if you get, you have a 20-foot line set with a 20-foot rise, you're going to want to start looking at, you see the gray over there? That means you can't really do it because it's a 20-foot line set and a 25-foot. So the bottom is your total and the left side would be your lift. So once you get up to like 80 feet, you're going to add subcooling for lift. Okay. 80 to 150 feet, you're going to be adding subcooling for lift. So just remember that's in there, and it's only listed in the service facts. This is not in the install guide, it's in the service facts. Basically what it is talking about subcooling and superheat. So for subcooling, the refrigerant comes out of the compressor into the condenser. It's 100% vapor when it goes into the condenser. As the fan blows across the coil, it cools down the refrigerant and turns it to a liquid. As it turns it to a liquid, it takes the saturated temperature, which is liquid and gas together. Once it gets down to 100% liquid, it starts picking up subcooling. So anything below the saturated temperature is subcooling. Okay, so what reason we need subcooling is so that we have 100% liquid at the orifice or the TXV when it goes to regulate the refrigerant through the orifice. Okay, we need 100% refrigerant there. As it goes through your TXV or your orifice, it's going to be a liquid changing to a gas. So what we're going to do is blow air across it. So we're going from a liquid, now we're absorbing heat into the refrigerant. As we absorb heat into the refrigerant while it's a liquid and a gas, it's going to go through the coil, and as it gets to the spot where it's 100% gas, then it starts picking up superheat. So superheat is the temperature of the gas above the saturated point, above the saturated temperature. Okay, and the reason that we need superheat is to prevent liquid refrigerant from getting to the compressor. That way we don't recondense our refrigerant in the line set getting back to the compressor, because we cannot compress a liquid. Okay, so that's basically the gist of superheat and subcooling. And sorry I couldn't get the video working. So we can charge the heat pump. So to charge the heat pump, after we've gotten everything done with our evacuation, our pressure test, our evacuation, everything's done, then we're going to open the service valves. We're going to start the unit. Again, we need to let it run for 20 minutes before we get our charge finalized, right? Okay, sorry about that. I got somebody telling me how to turn that on for the computer sound. So we're going to let it run for 20 minutes. We're going to verify refrigerant levels by subcooling in the air conditioning mode. That's the only way to certify the refrigerant charge for a heat pump. Verify refrigerant levels by subcooling in air conditioning. So if it's too cold outside to do that, then we need to verify the charge utilizing the heating charge curves in the service facts. Okay, so the charging charge go down to 55 degrees. That's why we can charge down to 55 degrees in cooling mode. Now it's not as accurate as if you wait till 65, but you can charge down to 55 degrees because we have charts that match that. Okay, so if you have a chart in your install guide or your service facts that goes down to 65, go to 65. If it goes to 55, go to 55. Whichever they can make charts for. I know other brands you can charge down to 17 degrees. So it just depends on where they're willing to make the charts down to, and whether or not they're accurate enough at those lower temperatures. We don't think that they're accurate enough below 55 degrees. That's why we stop at 55. So you're going to verify the charge using the heating charge curves and the service facts. And that's how you're going to set up your heat pump. You still need to come back in the summer when it's above 55 degrees outside, and preferably above 70, because you can really get a right-on charge that way. And then re-verify your charge when it's warmer outside. These are the pressure curves for heat charging. The one on the left is the high side. The one on the right is the low side. Those lines, the diagonal lines in the middle, are indoor temperature. The bottom is the outdoor temperature. So you're going to go outdoor temperature, say it's 35 degrees outside. We're going to go to the outdoor temperature. And then our indoor is 70 degrees. So we're going to go up to the center one, 70 degrees, and then we're going to go straight across to the left. So our high side, when charged properly, when our airflow is correct, is going to be about 330-ish. And then on the low side, we're going to go over to 35 degrees. We're going to come up to the indoor temperature. And we're going to come straight across, and our indoor temp, so our suction should be around 88-ish. So again, outdoor, indoor, straight across to the pressure you want. If you're below the line, you're going to add refrigerant. If you're above the line, you're going to take refrigerant out, and that's on the high side one. The low side's for reference. The high side, that's what we're charging to, because those are basically the subcooling charts in heat pump mode. Okay. And you guys tell me if you can hear it. If you can hear it, we'll leave it on. If not, we'll just skip it. Great.
A working knowledge of superheat and subcooling is as critical to technicians as our working tools and equipment. Hi, it's Paul again. Measuring superheat and subcooling is essential for optimal performance of a refrigeration system. First, let's look at superheat. As refrigerant enters the evaporator, it's in a liquid state. As heat is added to the liquid, it will turn to a vapor at its boiling point, or saturation temperature. After the refrigerant has boiled to vapor, any temperature of the vapor above the saturation temperature is the superheat. Superheat is then any temperature of a gas above the boiling point for that liquid. The superheat calculation lets you know if the amount of refrigerant flowing into the evaporator is appropriate for the load. If it's too high, then not enough refrigerant is flowing to the evaporator, resulting in poor refrigeration and excess energy use. If the superheat is too low, then too much refrigerant is flowing to the evaporator, meaning liquid is getting back to the compressor and causing damage. Now let's look at subcooling. As refrigerant enters the system's condenser, it's in a vapor state. As heat is removed from the vapor, it will turn to liquid at its saturation condensing temperature. After the vapor has turned to liquid, any temperature of the liquid below this saturation condensing temperature is called subcooling. Because the efficiency of the system is optimized with subcooling, you want to make sure that you have a constant supply of liquid to the evaporator. So it's important that the refrigerant is subcooled to prevent it from turning to gas before it gets there. A smaller amount of refrigerant is required to maintain the desired temperature, which means less work for the compressor. Now that we've gone through the definitions, let's review how you measure them. Subcooling is determined by using the high side manifold gauge to measure the pressure of the condenser. This pressure must then be converted to a liquid saturation temperature using a PT chart or the temperature scales on the gauge. Next, measure the actual liquid line temperature using an accurate temperature probe and subtract it from the liquid saturation temperature. The result is the subcooling value. Conversely, superheat is determined by using the low side gauge to measure the pressure of the evaporator. This pressure must then be converted to a vapor saturation temperature using a PT chart or the temperature scales on the gauge. This temperature is then subtracted from the actual suction line temperature measured using an accurate temperature probe. The result is the superheat value. If you're using a refrigeration system analyzer, simply select the appropriate refrigerant and connect the hoses and thermocouples to the system for an immediate reading. The unit will automatically determine saturation temperatures and calculate the superheat and subcooling. For the most precise readings, make sure your refrigeration system analyzer has elevation compensation settings and accurate temperature probes. That's it for now. Until next time, thanks for watching.
So I've got a question on here. I've been told suction pressure is a great tool for diagnostics because expansion valve can adjust even if the charge is low. That is correct. So what we're talking about here is pressure curves for the high side. And again, the low side is just there for reference so that when you're checking your high side, if you look over there and you see that your low side's all the way down to 30 or 0, you know something's going on. You know, your TXV or whatever is not working right, something like that. Okay. So it's just there for reference. Basically, you're looking at the high side, you're looking at the subcooling, and that's going to get you close until you can come back in the summer and do a true subcooling check in air conditioning mode. Startup sheets. Make sure you're doing startup sheets when you're doing install. It doesn't really have to be a full-on startup sheet. What you want to do is you want to write down the pressures and the temperatures and the airflow, all the stuff that you measured during your install. You just want to have some kind of a check sheet and have a sheet that you write down the pressures and temperatures. We have a whole bunch of different ones. We utilize our sheet, our Gensco quick form for a lot of stuff. We send it out for just about everything when guys are having issues. Because if you fill it out 100%, most of the time you are going to see the problem just by looking at the pressures and temperatures like a snapshot. Okay. So when you're looking at it, if you write it all down, you're going to be able to see that information. Okay. So this one here, this one's basically for a 3-phase unit, heat pump or a gas furnace or air handler. This is usually used for some kind of commercials where I usually use that one. This one here is just an air conditioner heat pump. It's just a different style. This one here is the Gensco quick form. It's got the gas furnace information on the front if you're having a problem with a gas furnace, model, serial, homeowner information, everything we would need to know in case one of us has to come out and take a look at your equipment with you. And then this is basically what I'm talking about when you fill this out. If you fill out everything on this form, you're going to figure out what's wrong with it. And if you can't, you can send this to me and I can look at it. If I can't figure it out, I can send it to the factory. And if they can't figure it out, they can send it to the engineer that actually built that product to say, okay, we did everything you told us to do. Our airflow is spot on, our pressures and temperatures, and it's still not doing what it's supposed to do. Help us out here. So this is the biggest reason to fill out these forms. Now, on the new equipment coming out, the Link stuff, it's going to have automatically inside the computer. You're just going to hit run report, and it's going to run a homeowner report, and it's just going to say green, yellow, or red. Your system is good to go. Your air handler is having an issue, and it'll be yellow. You should have it checked, or red. Your system is not running. You need to have it checked by a service tech right away. And then there's one that's for you and your office that you can download all the numbers. So you download all the numbers, send it to your office, put it in the file, and there's your startup. So if you have an issue with it 3 months down the road, you have your startup information that you can send to me, and we can look at today's versus your startup and figure out what changed. Okay. And again, we can send it to the factory if we need to. So we want to make sure that we're doing all these startup sheets on everything. Okay. The more information you give us, the better information we can give you. My brain is not a computer, but it kind of works that way. Garbage in, garbage out. If you're not giving me accurate information, I'm going to tell you what I think by what you told me. So if you're telling me one thing and the actual is something else, and I tell you, okay, this is what's going on, you probably need to replace your TXV or whatever. And then, 2 weeks later, you call me back and say, well, I changed it and this, but then you said, well, oh yeah, and I forgot to tell you that, well, I don't think my reversing valve is switching back and forth correctly. Well, that could be an issue why we're not getting refrigerant through the reversing valve, right? So, I mean, that's just an example, but garbage in, garbage out. So be as accurate as you can on these forms. And that way it's better for you, it's better for us, and we're going to get your system back online faster. Okay. So the service facts come with the units. So every unit has a service facts, and it has an install guide. Okay. So in there, that's where you would find that. If you don't have it, say whoever installed it did not give you or didn't leave the stuff for you, then you can look it up in Comfort Site or DealerNet. And I'm going to go into the trained Comfort Site, and I'm going to show you guys how to look that stuff up. Okay, give me just a second here to get in. The measuring the line set length is only to get you close. So the question is, when I first started this trade, manuals used to give a formula to measure the line set length and deduct the measurement from the factory pre-charge length. Is that no longer an option? It is an option. It is still in the manuals. It is not recommended because, and this is a Gensco thing, not a train thing, we cannot guarantee the charge in the unit. We've seen too many issues with units coming overcharged and undercharged. And I'm not saying every one, I'm saying there have been some. I've had units that have come with a double charge. So, and I can understand why it happens, because they're working on the unit, they hook up that thing, the lunch bell rings, they don't remember if they pushed the charge button before they left. So they get back from lunch, they push the charge button a second time, not remembering they did it once, and lo and behold, now we have a double charge in it. Okay, the factory says it can't happen. It's happened. So we would prefer you to start the equipment and to charge by subcooling or by the service vacs. And the other reason is that if you put a whole bunch of refrigerant into your if you put a bunch of refrigerant into your line set and then you open it up, you're washing out a lot of the oil. So we prefer you not to do that. We don't want you to wash the oil out of the equipment. So that's just something that, you know, it's better not to do if we can get away from it. All righty, so can everybody see the comfort side on there? Okay, perfect. All righty. So what we're gonna do, so let's go over number one. We're gonna look up how to find the information. So we're gonna go to product information. We're gonna go to product literature. We're gonna look for whatever we're looking for, an outdoor unit. We're gonna go down and find our model number that we want. So let's go with 4TWR5, 15 SEER heat pump. It's got the submittal, the product data, the installation, the service facts, everything right here. You just click on it, it'll download it, and you can view it. So this is going to select your exact model number. Boom, there it is. Okay, you can do this online if you have access to Comfort Site. So this one, if you guys don't have access to Comfort Site, get with your boss at work and have them get you access to Comfort Site for information like this and for training. Okay, so there's trainings in there you guys can take for free. The link training coming up, you're going to have access to the link site to be able to see the Bluetooth equipment. Okay, so make sure you get your access before you come to the link class. And if you don't have it, come anyway, because there are 24-volt modes that we're going to go over as well. You're just going to need it before you can log in to the equipment at the homeowner's house. Yes, you can charge an AC at 55 degrees with subcooling. As long as the charts tell you you can, you sure can. The quick sheets are in Gensco Customer, and I'll show you that here in just a minute. Let's go through the rest of this one. So go back to product information. We're going to get back out of this. So all the information is right in there. Here's the tech support tab right there. So tech support, refrigerant piping program. And this is the same program that we've been using for years. Go to installation. Select the type of unit, heat pump or air conditioner. Select the family. This time we'll do a silver 15, which is our American Standard 15 SEER. We will select a 3-ton unit. And it populates the refrigerant type automatically, even though we already know it's a 4. So that's for 410A. It tells you what kind of refrigerant. Then we're going to go over here. We're going to select the location. Is it above or below or horizontal to the indoor? So the outdoor is above the indoor in this case. My total line length is 75 feet. My vertical change is 20 feet. I have 0 short elbows because we don't use short elbows. We only use long elbows. I'm going to have 6 elbows and I'm going to have no underground tubing. I'm going to hit calculate. It's going to tell me the line set size that I can use. 5/16 or 3/4. I'm going to need to add a compressor sump heater and an indoor TXV because of the length of my line set. Okay. So if I have an alternate size, like 3/8, we always use 3/8. We almost never use 5/16 because it's more expensive. So we'll go 3/8, 3/4. Boom, done. Okay, tells us how much charge we're going to add extra. Okay, it's going to tell us what required accessories we need. It's going to tell us the pressure drops. Now, if we go back here and we change this to, let's say, 150 feet and hit calculate, it's going to tell us we need 3/8, 7/8. And it tells us the alternate sizes over here. So let's just check one and see what happens. See, it doesn't. 3/8. Okay, so we can't use a 5/8 because the pressure drop's too high. See what we did there? Even though it's okay to use it on some links, not for this. So let's try 3/4. Pressure drop is high, but it's yellow. So this means if you absolutely had to, you could use this, but you don't want to. You want to go ahead and use 7/8. Anything is white is good. You know you can do it, no problems. Yellow is caution. Red is do not do. Is that better? Can everybody see that? Okay, sorry about that. Okay, let's start over. Go up here, heat pump. You're going to select your heat pump. Select the family. Select the model number within that family, basically the size you want, or your exact model number of the equipment you're going to put in. Select the location above or below. Total line set length, vertical change, and how many elbows. Then you're going to hit calculate. It's going to tell you what size to use, 3/8 or 7/8 over here. And then on this side, it'll be blank, but you can populate the size that you want. See how we changed that to 5/16 and it went to yellow? That means it's a big caution. Don't use 5/16. Okay. We'll change this back to 3/8. If we selected 5/8, it goes to red. Pressure drop's too high, so don't use it. Let's go to 3/4. Yellow again. This is for if you absolutely had to use it this way. Okay. I wouldn't use it just because we have a high pressure drop. You don't want high pressure drop. You can cause problems. Okay. So we're going to select 7/8 and it goes to all white. When it's all white, that's good. Okay. So you know that you could use this. Okay. So this works for all the equipment. The only thing you want to be careful of is variable speed. Use the variable speed charts that are in the variable speed manual. Double check this program with that before you just go by this program on variable speed. Okay, so there's certain units that you cannot, you can't use certain sizes with for variable speed. So just make sure that you're looking at it. Anybody have any questions on the piping program? Okay, now back to comfort site, product info, performance and utility data ratings. This is the HRI. Current ratings or ratings archive. So right now, what's in the current ratings are the new SEER 2 stuff. So if you go to current ratings, you may not find what you have in stock at your shop. So you can go to ratings archive, go down and select your outdoor unit first. So we'll just go with the AC this time, 4TTR3. So it's a 13 SEER AC, 3-ton. Hit search. Then it's going to bring up all the ratings for the different 3 tons, N, H, G, E. So depending on what your exact model number is, you're going to select for the exact model number. Okay, so let's go for the N's because those are what's out now. And here's all your coil only matches right at the top. Hit the wrong button. I'm not having a good technical day. I'm sorry. So there's our coil only matches. Scroll down a little bit more. There's the air handler matches. Scroll down a little more. There's a gas furnace with a condensing unit and a coil. Okay. So that's how you find it. And then once you find it, you go to the AHRI reference number and you can click on that AHRI reference and there's your expanded rating right there. Okay. Those are capacities with temperatures, capacity multipliers for the airflows. Tells you what they set the airflow for when they did the test. So they got all that information right in there. Does this work for VRF? For mini splits? No. For our variable speed equipment, it does, but you will need to verify it with the service manual for the variable speed to make sure that you're not exceeding the maximum size in the service manual. All righty. Anybody else have any more questions?